Hello and welcome to Pharma-info with Shubhashish. Now today's topic is synthesis of procyclidine. This is as per PCI syllabus, medicinal chemistry 1. Now procyclidine is a drug which basically belongs to the pharmacological category of anticholinergic. And what are the clinical conditions in which procyclidine is found to be the drug of choice? The first thing is Parkinsonian. So it can be used in the treatment of Parkinsonism, and that is why it is called as anti-Parkinsonian agent, right? Though it cannot, suppress each and every symptoms associated with Parkinsonism, but still, rigidity, tremor, akinesia, right? These are the few symptoms on which this particular drug can work, and that is why it is found to be a choice. Till now, it's a choice. It's not an extinct one or discontinued. Rather, it's still there in the market, and it is used as a anti-Parkinsonism to basically address rigidity, akinesia and tremor. Fine. These three symptoms can be treated with procyclidine. Now coming to the structural feature of procyclidine, as we all know that synthetic anticholinergic blockers, they are basically following a template structure, and the template comprises of what? Two bulky rings. They are connected by means of a neck, and neck should be essentially comprised of electronegatives, followed by a homologous series of hydrocarbon, and followed by a nitrogen which is tertiary in nature. So this is found to be the common template. Now on the basis of this template only we are trying to draw the structure of procyclidine. Now before that, let us do one thing. Are we able to find out, or rather extract, any kind of structural information from the structure, from the name itself? That is procyclidine, right? Let's do one thing. Let us just see that one. So pro corresponds to propyl, right? Fine. Cyclidine, that means cyclic system should be there, right? Cyclic system, it may be alicyclic, it may be aromatic, right? There are chances that these two combinations may be there, okay, with this particular drug. Now, and lidine corresponds to a heterocyclic nomenclature says if a 5-membered system comprises a 5-membered heterocycle is having no pi electrons, that time we can end up the process with lidine. Like yours, assume that this one is pyrrole, right? This one is pyrrole, right? 1H pyrrole. Now if pyrrole is, right now pyrrole is having two pi bonds, pi bonds, right? Now if I just remove these two pi bonds, it turns out to be pyrrolidine, right? So from here only the concept of lidine came into existence, right? Fine. So it is the concept that eventually give rise to the formation of this kind of name, right, sir? So with these three informations, let us just try to figure out the structure. So bulky, as I said, cyclic system, okay, cyclic system, it may be a combination of alicyclic as well as aromatic. So likewise, as two ring system should be there, and they are connected, they must be connected with a neck that comprises of electronegatives, right? And the electronegative is found to be the hydroxyl, and here we are going to put what? Phenyl, right? Chalo. So one is alicyclic, the other one is aromatic, followed by a electronegative atoms. So likewise, so bulky rings which are kept over here, electronegatives already there, and followed by a homologous series of hydrocarbons. So here we are going to put what? CH2. Why? Because procyclidine starts with pro corresponds to propyl, and propyl corresponds to 3. So 1, 2, 3. Fine. So 3 we are done. Then we are left with what? The terminal nitrogen. That must be tertiary in nature. Whether the nitrogen is found to be an open one or a closed one, right? It can retain its tertiary state, right? So assume that if it is a closed one, this could be the final shape which of the tertiary or the terminal nitrogen. Fine. If it is found to be incorporated in a cyclic system, then also it can retain its tertiary nature, right? So likewise, it is complied with what? The template requirement or template structure of anticholinergics. So with that we are done with what? The structure of procyclidine. Now let's talk about the IUPAC naming and all, right? So now here we have three cyclic structures, right? One is cyclohexyl, the other one is phenyl, and the third one is pyrrolidine. So this one is C, this one is P, and this one is P, right? Chalo. So now the thing is that, so here only one parent functional group is there. We are not in a mess. Why? Because here we have to deal with what? Only one functional group. So by default this will be considered as a parent functional group. So parent functional group is found to be a part of what? Aliphatic chain. Fine. So we need to find out that the longest aliphatic chain, and it comprises of 3 carbon, 1, 2 and 3. Fine. So 3 for propan. So basically this is propanol. And now we need to see propanol comprises of various substituents. At position 1 and position 3, both are being inserted with what? 2, 3 cycles, right? So one is phenyl, the other one is cyclohexyl, and the third one is pyrrolidine. So let's do one thing. Let us just give the priority to the alphabetical order. So C comes first, and C is attached to this carbon. C means cyclohexyl. So this one is what? 1 cyclohexyl. It starts with 1 cyclohexyl, then followed by 1 phenyl, right? And then at third position we have pyrrolidine. So likewise 3 pyrrolidine, 1 yle, because pyrrolidine itself is a substituent. So 1 yle followed, and we are left with what? The parent, that is propan or prop-1-ol. That's it. So this is all about your IUPAC name of what? Procyclidine. Now let's talk about the synthesis of procyclidine, right? So this one is procyclidine, this one is procyclidine. Let's do one thing. Now, so this one is procyclidine. Now let us do one thing. Let us just figure out the possible fragments, right, which can be emerged out of dissection process. If I want to demolish the entire compound, definitely it will be demolished into several fragments, right? And after that, if I just combine the fragments in a proper or synchronized way, it gives rise to the structure of procyclidine. So after all, it is the combination of various fragments that constitute what? An entire building, right? And each and every fragment should be a part of an individual reagent, right? So this is the best way. First, you break the compound and get the fragments, complete each fragments, and just try to bring each and every fragments in a sequential way, so that you can get the structure, you can generate what, or develop what? The building. Fine. So likewise, let's do one thing. We can do one thing like this. We'll just isolate the portions, right? This is the first one, this is the second one, this is the third one, and this one is the fourth, right? So thus we have with us 1, 2, 3 and 4, right? Now let's do one thing. Let us just complete each and every fragments, right? Let us just complete each and every fragment. So this one is the first one. So first one comprises of what? The first one comprises of a phenyl with CHOH and C double bond O. We all know that it is the carbonyl group that can be converted to, upon reduction it can get converted to what? Hydroxyl. Fine. So likewise, this could be the final form of this fragment, right? Final form of this fragment. So thus we can say this is one of the essential starting material, one of the important starting material, and the name of the starting material is what? Acetophenone. Acetophenone. Right. Now to that acetophenone I need to connect one CH2. We know that the source of CH2 could be an aldehyde. So likewise, let us do one thing. Let us bring what? Let us bring HCHO. But here we are going to put here N or X. So this is called paraformaldehyde. Paraformaldehyde. Right? Because aldehyde is found to be a suitable source of inserting what? CH2 or methylenic moiety into a system, or in, right? Chalo. So we are done with the second fragment as well. Now coming to the third fragment, right? So the third fragment should be inserted or should be linked with what? This CH2. So likewise, the third fragment should be a heterocycle, and that too a saturated heterocycle, and it comes out to like this. Comes out to be like this. Fine. So now we have developed the third fragment as well. So this is nothing but 1H pyrrolidine. Now if I just condense all these three, right? So what will happen? Let's see. So now when these three will get condensed, right? What is the outcome? The intermediate which is likely to get formed out of this combination or condensation is something like this. C double bond O, CH2, then CH2 from this paraformaldehyde, followed by a direct connection with what? With the pyrrolidine, right? So with that we have already developed what? The backbone of procyclidine. Fine. So now what is left in the process? Now only thing is that we need to bring one cyclohexyl, the fourth fragment, right, and we have to convert this C double bond O into CHOH, right? So for that, what am I supposed to do here? I need to bring over here Grignard reagent, right? So here the Grignard reagent can be a cycloalkyl. That means here I need one cyclohexyl, fine, cycloalkyl, right? Then after this cycloalkyl, MgBr. So this is found to be the Grignard reagent. So I can bring here cyclohexyl magnesium bromide, right? So what this cyclohexyl magnesium bromide will do? Cyclohexyl magnesium bromide will be definitely, give its cyclohexyl group to this particular carbon, right? So thus we can get what? Cyclohexane. This will get converted to CHOH, followed by, beneath this we have a phenyl. Finally we have CH2, CH2N, then hydrogen. So with that we are done with the structure of what? And thus we got what? The procyclidine, the structure of procyclidine. Fine. So you may find that instead of taking cyclohexyl magnesium bromide, sometimes this is found to be the first way. The first way. We have another way as well. The second way is, instead of this you can also take what? Phenyl magnesium bromide, right? If we are going to take phenyl magnesium bromide, what will happen? Another step we need to conduct. The phenyl magnesium bromide will release this phenyl and just place it here, right, instead of this cyclohexyl. So later on this phenyl need to be further reduced, right? And in that very process of reducing the phenyl, what you need to do, that is platinum oxide. You need platinum oxide for the purpose of reduction. Fine. Platinum oxide, hydrogen, right? So this need to be taken so that this phenyl can be converted to cyclohexyl. So straightway I think that you should opt for the first way. That means straightway you can just take cyclohexyl magnesium bromide and just treat this one with the cyclohexyl magnesium bromide. So this one is intermediate one, right? So that has to be treated with what? Cyclohexyl magnesium bromide, and later on this cyclohexyl magnesium bromide will get inserted over here, and in that very process of reacting with Grignard reagent, what will happen? The C double bond O will no longer retain its carbonyl state, rather gets converted to CHOH. So here hydrogen is not there because the hydrogen is replaced with the cyclohexyl. So thus we got the structure of procyclidine. So hope you have understood, right, how procyclidine can be synthesized and what is the actual structure, what is the way, or which is that way by which we can develop a structure without giving some pain to our brain and all, right? Because the strategy should be adapted in such a way so that you can extract the structural information from the name itself, and thereafter you can create the final compound, right? So this is the way of making what? Procyclidine. Hope this is clear to you. If there is any doubt and all, please put your comments so that I can get to know about the doubt, and accordingly I'll just tune my way of delivery and all. So this is all about today's procyclidine. Hope we can come in the near future with few more interesting topic. So thank you so very much. If you like my video, then please do subscribe my channel and put your valuable comments. So thank you.